Devastating flooding hits South Africa.
Bridges have been broken, businesses have been destroyed.
Sea ice dynamics and the discovery of the shipwreck Endurance.
We tried to forecast the location of a series of buoys that are frozen into the ice, so they take observations there.
It's Friday, the 22nd of April, and you're listening to Weather Snap from the Met Office. Last week, South Africa suffered one of the worst natural disasters in its history when a catastrophic amount of rain fell in the Durban area, killing at least 448 people. Pusileto Omofu-Keng is a senior forecaster with the South African Weather Service and described the impacts of the heavy rainfall to climate correspondent Graham Madge.
This extreme flooding event actually did occur in the province called KwaZulu-Natal. The municipalities would be Ugu, Umzimkhulu, as well as eThekwini and Mgungundlovu. eThekwini is by the capital city, Durban. That's where we had the highest number of lost lives and the highest damage. Bridges have been broken, businesses have been destroyed.
We know from TV reports in the UK, we know that this has been a very tragic event with loss of life. How unusual is this kind of flooding event for South Africa?
It is indeed unusual, but obviously it is not the only event that we are experiencing. Just recently, in 2009, around the 22nd to the 24th, we had yet another or a similar cut-off flow that brought similar events. Ugu District Municipality is the second time to have this high impact. Also in the Eastern Cape, which is not so much affected this time around, but in 2019, a similar event did occur where we had a lot of mudslide, including damage to property and the lives, of course. At the time, we lost about 85 people. So this time around, it's near 450. So it's actually a high number of people that had died.
Could you explain what the weather drivers were leading to this event?
We were guided by a cut-off low pressure system from the western section of South Africa, moving forward to the eastern section. In other words, off the east coast of South Africa, that's where the surface low that is actually supporting the cut-off low was situated. Because we do have the Agulhas current running approximately 20 kilometers away from the coast, and the low pressure system sitting over that Agulhas current, we then had an influx of moist air conditions, which were persistent. The strength of the wind, the moisture that was influxed there, actually played a big role.
Pusileto Omofu-Keng. As well as dealing with the immediate aftereffects of devastating floods, it's important to try to understand how climate change may have contributed to this latest extreme weather event. Here's Rob Allen of the Climate Monitoring and Attribution Group.
The project has many aspects, and the one that I'm particularly involved in, which is Work Package 1, is to do with the recovery, imaging and digitisation of historical, terrestrial and marine surface weather observations. So we're trying to improve the quality and quantity of those data. What we want to do is, if we can recover this sort of data, is that it's made available to weather reconstructions, which are called reanalyses, which allow us to look at the full three-dimensional aspects of the atmosphere. And what we're doing is getting this back over the last couple of hundred years to be able to look at events such as storms, droughts, whatever, so that we can put the situation in more current times into a longer and better perspective.
This event has been reported widely as a very tragic and dramatic rainfall event. Do you think it's likely, through the work that you're doing, that we may discover that there may have been more extreme events in the past?
It's quite possible with the work that we're doing in the reconstruction. The current situation, we think, is part of a protracted La Nina episode, which I believe probably started around about July, August of 2020, and it's continuing on. And these sort of things can have very important impacts.
Could you briefly explain a little bit about the ENSO cycle and how that may affect South Africa?
ENSO is El Nino Southern Oscillation. It's a large-scale ocean atmosphere phenomenon which involves interactions between ocean and atmosphere. In the core region is the Indo-Pacific region. When these events are very strong of El Nino or La Nina, they're the two extremes of this ENSO phenomenon, they can be near global in their impact. So, for instance, Southern Africa, like many other places during ENSO and cycles El Nino and La Ninas, has had some very bad droughts and very bad floods. Hence, we've been looking very carefully at those. So it is a natural phenomenon, but there's nothing to say that changes in climate due to warming of the atmosphere couldn't change the background conditions, if you like.
There has been some discussion about whether this event is linked to climate change. El Nino, La Nina cycle is part of climate variation. So do you think this is climate change or is this just climate variability?
We believe that in a warmer world under global warming, therefore, if it's just the warming continuing, therefore more water vapour held in the atmosphere, then events like El Ninos and La Ninas could be markedly affected. We don't know. We're still trying to tease that out. So longer, better data, etc., is going to be important. And there were certainly suggestions with the protracted El Nino in 2018 to 2020, the heart of the Australian drought, that climate warming may have had a part in exacerbating a natural situation.
Rob Allen talking to climate correspondent Graham Madge. A search team in Antarctica announced the astonishing discovery of Sir Ernest Shackleton's expedition ship Endurance. The ship has lain 3,000 metres down on the bed of the Weddell Sea ever since it was famously trapped and crushed by sea ice in 1915. The search team was assisted by experimental sea ice forecasts produced by the Met Office. And earlier I spoke to Ed Blockley, Scientific Manager for Polar Climate, who explained the contribution.
Our models forecast sea ice at both poles. We run a global model, but in the Antarctic, the quality of the forecast is relatively unknown. And so we've been contributing these experimental forecasts to try and work out how good they are. And we have supported the Endurance 22 campaign by providing forecasts from our operational models.
Can you explain in simple terms how the observations are produced and processed and what value this has?
So as part of this research activity, which is called the Sea Ice Drift Forecast Experiment, we try to forecast the location of a series of buoys that are frozen into the ice. So they take observations there, and we try and forecast the location of these buoys using the model velocities. And what we've done for Endurance campaign is that we've also included the ship as one of these buoys and just tried to forecast how the ship would drift with the ice if it was left to do so.
So there's quite a small window where people can come along and try and locate something like the Endurance, because obviously the sea ice starts to build from this point onwards. Am I correct there?
The Antarctic sea ice generally melts away during the summer, but it does remain all summer in that area of the Weddell Sea, particularly against the Antarctic Peninsula near to where the ship capsized. And so there's only a small window of opportunity to get in there. You've still got to navigate through the sea ice, but it's an easier job than if you went in the winter. You'd have a long way to go through the sea ice.
These forecasts are important, particularly with research vessels which are deliberately heading into the ice. And obviously your data is used not just for finding sunken ships.
We provide these forecasts every day, actually, from our model, but it's very interesting to us to know how well they can work in the field. And we previously have provided forecasts for the Mosaic campaign, which was a year-long expedition where they froze a icebreaker ship into the ice in the Arctic and left it there for a year. And our forecasts were used on that campaign to help them to order satellite imagery so they could estimate where the ship would be in the next day or so.
That's fascinating. Just getting back to the Endurance, I presume it wasn't just luck that they found it in March. There is a reason why they were looking for the ship at this time of year in this part of the Antarctic.
Yeah, so March would be the end of summer in the Antarctic, and that's the point at which the sea ice extent is lowest. And so the conditions would be most favourable for them to find the Endurance then.
Ed Blockley. Now here's Greg Dewhurst with the latest weather outlook for the UK.
So as we go through into this weekend, we're going to see low pressure to the south of the UK and high pressure to the north of the UK. And what that means is we're going to see quite a brisk easterly wind across most parts, particularly the east of the UK, where winds will be coming in off the North Sea. So this is going to drag in a lot of low cloud through Saturday across some eastern parts. It should lift and break as the day goes on. Best of the sunshine will be across western areas, and in the sheltered west on Saturday we could see highs, the mid to high teens locally, so still feeling warm in that sunshine. But under the cloud, where we see any showers, it will be a little bit chillier than we have seen of late, particularly with that easterly breeze. And the sea temperatures at this time of year, 6, 7, 8, 9 degrees. So the wind coming off the sea will really impact the temperatures on some coastal areas. Very similar into Sunday as well. We continue to see the risk of 1 or 2 showers. A lot of cloud across central eastern parts, the best of the sunshine in the west, where temperatures again will reach the mid to high teens, particularly southwest England, western Scotland, Northern Ireland, West Wales too. The east, we will see some brighter skies at times, but quite chilly in that easterly breeze. Looking into next week, well, we've had a very dry month so far, and it's looking very similar through the week ahead with a lot of dry weather to come. Winds generally turning a bit lighter than they have been over the weekend, but generally for most, the dry theme continues.
Just before we go, here's Martin Bowles with last week's highs and lows.
Here are last week's UK weather extremes. The highest temperature of the week was 23.4 degrees Celsius at St James's Park in central London on Friday. This was the highest temperature of the year so far. Overnight air frost continued in a few locations. The lowest recorded temperature was minus 1.4 degrees at South Newington in Oxfordshire in the early hours of Monday morning. The largest daily rainfall was in Northern Ireland on Sunday. 29.2 millimetres was measured at Loch Fee near Cookstown on Sunday. The sunniest county was Dorset in the south of England. On Friday, 12.7 hours of sunshine was recorded at Herne Airport near Bournemouth.
Thanks, Martin. That's it for Weather Snap. I'm Clare Nasir. Editor is Adrian Holloway.
Weather Snap is a podcast by the UK Met Office. For the latest weather conditions where you are, download the Met Office weather app.